Good evening, everyone. Can you hear me?
Yes, we can.
Okay, thank you. I'm just going to load my slide. Okay, good. All right, good evening, everyone. I'm going to start the session. I think we can, I don't have to wait any longer. We're going to be talking about data capture and analysis this evening. So we're moving on to Unit 3 of the program. Before I start the session, I just want to apologize for the delay in providing feedback for assignment 1. I had planned to do the marking on Monday and Tuesday, but I haven't, because of other problems, I wasn't able to. So I'm going to do that in the next couple of days, and I'm going to move the hand and date for the second assignment to Monday next week, just in order to give you a bit of extra time and also to get feedback before handing in the second assignment. Okay, so sorry about that. All right. Today we're going to talk about the later stages of the research process. So we've covered design of the project, and we've covered sort of different research strategies that we can use to conduct research, and sort of emphasizing the ones which are more quantitative in nature. And then we've also spoken about populations and sampling in a quantitative way. And we're now going to move on to we've also spoken about data collection tools, which we can use for quantitative-based research. So in the last unit, or in the last two contact sessions, we're going to be focusing on capturing data and on analyzing data. So how do we support students in terms of data capturing and in terms of analyzing data? So we're starting this evening with some sort of issues around fieldwork and data capturing. And I'm also going to do a demonstration of some software that we use to conduct statistical analysis. So introducing this idea of analyzing data, and then what could a student use, for example, to analyze data? Okay, so the first topic is data collection. I'm not going to spend too much time on this topic. So I'm just going to ask a question. I'm not so much worried about all these separate questions. I'm not going to use breakaways because it's a very small group. But I think the question is, what have you experienced any challenges with field work, if you're doing quantitative work, or even, you can also talk about qualitative work if you want to, and how did you resolve those challenges? So that's the question. Let's focus on that question. So have you had any experiences where you've been conducting field work and you've had challenges, or if one of your students has been conducting field work and if they've had challenges, what was the challenge and how was it resolved? Is there anybody who wants to talk about that issue, this issue of field work, and any challenges, or have you always had perfect experiences with your research projects? So I'm opening the floor. If you can just unmute yourself if you want to talk about your project or one of your students' projects. Does anybody want to talk about their experience? Oh, okay. So, yeah, philosophy. Okay. Yeah, you can do primary research with philosophy. So that's not that you can't do it. It's just obviously the kinds of designs that you're using are not fieldwork orientated. So maybe the idea would be to think about or have a look for research where researchers in the field have done research where they've collected primary data and see how that might apply to your sort of area, or there might be an area of research that you might be interested in doing. Okay.
Can I push a little, Doc?
Yes, yeah, sure, yeah.
So I with my PhD particularly, I didn't necessarily have to do field work, but I did put myself outside there almost for personal experience. And the research I was doing was like research within prisons. So I went to the what is it the Sun City prison, which is the Golden Highway prison. And I realized only after going there certain things which could have been dangerous, or situations that we hadn't maybe foreseen. And so one has to 100% uh, understand various things about the people in the place that they are researching. That place, fortunately, there was a space for the kind of research I was doing, because there was some interest from the prisoner population. But I just imagined outside of that and what we were presenting them, that one's positionality is really something you have to consider before going into field work.
Yeah, definitely. Yeah. I think it depends on what you're doing as well. So I think certain kinds of topics will be more difficult to navigate than others, depending on what kind of topic you're working on. So I think that's, but if you're working in a prison context, that is particularly sensitive. So I think that would definitely be a area where you would need to, yeah, be quite careful about how you navigate the research. There's actually a very interesting paper that I sometimes refer students to based on a prison example, where they do a quantitative study and then they actually go back um, to the participants to follow up on the quantitative, to do a more qualitative approach to find out why they gave the answers that they gave to the questionnaire. So it's an interesting sort of methodology of sort of mixed methods approach, where they did they used a questionnaire with people in prisons, and then they didn't understand why they'd chosen some of the ratings and things on the questionnaire. So they go back and conduct interviews with the participants to go into detail, and it kind of reflects that issue around the limitations of questionnaires in terms of the depth of data that you get from them, and sometimes you need to do those qualitative follow-ups. So that's quite an interesting uh, study, which I sometimes refer people to. All right, now I can't see any hands. Is there anybody else who wants to comment on field work? I can't see. I've got a thing in my screen. I see a person with one new activity, but I can't see what the activity is. um, I don't know if you're putting up hands or just entering the system.
Yeah, that's the class. Yeah, take your seat. And then we
All right, so as nobody else wants to comment, okay, let's carry on. All right, so when you when you going to collect data, you need to obviously reflect on the goals of the study. So you need to ask the questions: what are the main objectives of the study, and what is the problem you're trying to solve? And then it's also important, in terms of asking the right questions. I mentioned this before, that if you're not asking the correct research questions, you're not going to get the right data. So you need to determine exactly what you want to accomplish, and that should reflect in the problem statement. And obviously, if it's a student that's doing research for the first time, they might not have they might have a sort of good, reasonable problem statement, but it might be a bit sort of vague or not very focused, and that can lead to problems with the student getting the correct data. Then you also need to identify the practical or scientific issue that you're addressing. That's going to vary depending on the area that you're working in, obviously. And then you also need to think about the significance of what it is that you are researching. So why is it important to do that piece of research? So these are all kind of questions that you need to be asking when you start data collection to ensure that you're collecting the right kind of data for later analysis. Right. And then some problems that we see with field work, the student can't get the necessary permissions to proceed with the research. So the plan is that they're going to go into a certain community, and then they can't actually get access when it comes to actually doing the field work, or the right to access changes at some stage during the process. The other problem with quantitative research could be that the student can't get access to the target sample groups that they're looking for. If you're doing comparative analysis, you might not be able to get access to the different samples that you're interested in. The student can't achieve appropriate sample size, so the plan might be to obtain a sample size of 300, but you can only get 100, and that might impact on the kind of analysis that you might be able to do, or the representation of the sample in relation to the population. Other things students do is they leave fieldwork very late, and then that puts a lot of pressure onto the last stages of the research. So as a supervisor, you need to keep the student on track and keep monitoring the student throughout the journey to make sure that they've got time to do the work that they claim they're going to be doing. And it's not always easy. Sometimes field work does take longer than expected, and it can also cost more than anticipated. And that can be outside the control of the student. So they might not be able to control all the facets of the journey to the extent where they are late, and then a decision would need to be made about whether they need to re-register, whether they can re-register because they're late with their field work. But sometimes, quite often, it's because the student is procrastinating or not focused. They're not anticipating how long it's going to take them to do the work. They think they'll be able to do it quickly, and they can't, or it's going to take them longer than they anticipate. So as the supervisor, it's important to keep monitoring where they are, what stage they're at, have they got enough time to finish the work that they need to be finishing. And some organizations have milestones in place to help you with those kinds of deadlines. But it's also probably a good idea as a supervisor just to keep track of where the student is and keep monitoring them in terms of where they are. Okay. The other thing that can happen is the student sort of finds out that the data collection instrument is not suitable for the target sample. That should have been sort of uncovered where during the pilot phase, if you're doing a pilot phase for the study, but sometimes there might not be enough time to do a pilot because remember the students are often working under quite tight deadlines for their projects. And then they sort of go out into the field and realize that their instrument is not really working for the target sample. And then the other thing that can happen is important information can be lost during the fieldwork phase. So we've had stories about students with questionnaires in a vehicle, and then the vehicle gets stolen, so their data disappears. So that can all, and then there's the other thing would be if you have information on a computer, for example, and the computer crashes, that you need to make sure that you have backups or second copies of the data that you want to be working with, because that can be quite. At StatCon, we sometimes assist students with capturing questionnaires. And I'm always nervous about that period between when they hand the questionnaires in and when we've got the data onto the computer into a file. Because if the building burns down, for example, those questionnaires could be lost, and it's very difficult to make copies of 500 questionnaires, for example. It's not really a thing that you would think about doing. You might be able to scan them, but even that would take a lot of time. So it's not really the kind of thing that you think about doing. But there is that risk. There's always some risk involved of losing data. So I've got a colleague who says you shouldn't worry about it because it's a bad thing to happen, but it's not as critical as some other problems. But I still would be concerned if a student has spent a lot of time collecting data and then that data gets lost somehow. It's not a good situation for the students to be in. Okay, I'm also going to share a chapter by an author called Leviton, which is the title is How Numbers Are Collected. And he identifies a number of possible biases and inaccuracies and mistakes that can be made in the data collection process. So we've spoken about one of them before, which is that when we were talking about the design of the study, where we said that definitions, we can have multiple definitions for a concept, and it's about the choice, it's about making a good choice about which definition is used for the study. There can also be sampling bias. So Leviton is quite strongly in favor of using probability sampling for studies. We've spoken about probability sampling in an earlier session, where you would want to limit the bias in the study by using a probability method rather than a non-probability method of sampling. But that's not always possible depending on the context. We can also get participant bias, where those who choose to participate might be different from the population. And that's a common kind of social phenomenon where people who are interested in participating in the research don't necessarily represent the population that you're targeting for the study. And then you have to try and find ways of minimizing that effect. There's also reporting bias, which relates to the truthfulness of answers. We've sometimes seen studies from particularly in education, for example, where you have a questionnaire which has been sort of validated, and when you apply it with a group of learners, it comes back with very sort of odd-looking results. And that could be because the learners are not taking the exercise seriously, and maybe filling in nonsense answers onto the questionnaire. I don't think those kinds of things happen a lot in my experience, but they could happen. So you need to sort of take into account that there could be reporting bias from the participants. There's also lack of standardization. So this speaks to, we spoke about reliability in an earlier session, and this speaks to the issue of repeatability of the measurement. So is the instrument that you're using, whether it's a machine or whether it's a questionnaire, is it standardized in a suitable manner where you can where you'd be able to repeat the data collection and get a similar result if you were using the same kind of sample. And then the other issue there is your measurement should be unambiguous. So often with questionnaires, for example, there would be questions on the questionnaire which are very ambiguous in how they're worded. And that would give you, it means that different respondents will interpret the question in a different way, and that will give you ambiguous answers. Then there's measurement error. So there will always be some degree of measurement error. We never likely to measure something perfectly. And that applies to machinery or to other kinds of data collection instruments, whether you're using lab-based measures or questionnaires. There's always going to be variation in the measurement. And then the other problem is trying to measure things that are unknowable or unverifiable. So there's certain things that we can't measure. and there would be, it's about sort of acknowledging that you're attempting to measure something which isn't actually measurable. And I've come across a few examples of those, not so much in the work that we do, but in other kinds of contexts where somebody might claim to be measuring something which isn't actually measurable. Okay, so that's the issue of data fieldwork. If anybody has any other comments about fieldwork, you're welcome to raise them. It's just trying to support the student in terms of getting good, accurate data for their project. Okay, we're now going to move on to a more practical topic, which is data capture. So have you, just to kind of go onto the more to speak about challenges, is there anybody in the group who's captured data and had for their project and had problems with their data capture, and what was the problem and how did you deal with it? Or if your student had a problem capturing data, what was the problem? You can just unmute for talking if you want to talk. Anybody? Has anybody captured data themselves? Nobody. Somebody must have captured data. Okay, transcription errors. Is that for a qualitative kind of transcription of interviews?
No, transcription of categorical numbers.
Okay, how do you mean by that?
So when you're capturing the data, if you do it on a form and then you capture the data onto the computer, for example, into Excel, there can be some transcription errors transcribing from the one format to the other format.
Okay, do you mean sort of like the number, you put in the wrong number, or?
Yes.
Yeah, okay, yeah. So yeah, capturing the wrong numbers, yeah. Okay, anybody else got suggestions about any experiences of capturing data? Okay. All right, so I'm just going to move on then, if anybody wants to raise issues. So possible problems that students can have with the data capture process, and I'll go through an example of a couple of examples shortly, but the one would be that there's no code book. So when we create a data file, we need to have a code book, and the code book tells us what variables are being measured, and it gives details about those variables. And I'll show you some examples of a code book after this shortly. So, and it's critical to have that code book because it's your kind of it's an audit trail of what you're creating in that data set. And it allows somebody who's kind of using your data set or needs to refer to your data set to understand what that data set contains. And that'll become sort of evident once we do a couple of examples. There's also a poor quality code book. So the student has a code book, but it's not a very accurate one. It's not a perfectly accurate code book, and that can lead to misunderstandings of what the variables are, how they're measured, that kind of thing. Then there's the what we call maybe transcription errors, is the data capture errors that you make during the data capture process. So when you capture data from a form, for example, you need to take the information that's on the form and put it into a spreadsheet or into a database. And in the process of doing that, you can make mistakes. And I think some people are more accurate data capturers than others. They just have a skill for it. And there are people who are trained data capturers, so they're trained to not make errors. It's about, we call it attention, and in our sort of unit we refer to attention to detail. that you kind of very accurate about converting the data from the sheet, for example, into the spreadsheet. Another mistake that can be made is that not all data is captured. So some of the records might be omitted, so you've got an incomplete data set as a result of that. That you can also have a problem where you capture the same records more than once, and that does happen. I had an experience once with a researcher who basically doubled their data set. So what they did was they added one data set onto they kind of copied the data set and then added it onto the same data set. So they ended up with two sets of records, sort of so double records, but they were the same records, and that's really problematic for accurate analysis later on. Another problem can be that the data is captured in the incorrect structure. So when we do statistical analysis, we need the data to be in the correct structure to be able to analyze the data. So a program like SPSS, for example, will expect the data to be in a certain format for the analysis. And if you've got it the wrong way around or in an incorrect format, you won't be able to do certain kinds of analysis. Or if you've really made a big mistake with the structure, you wouldn't be able to do any analysis at all. And then we can also have the data captured in the incorrect format. What I mean by that is that the data might be sometimes when you collect data, it might be you might have, if you think about a questionnaire, the questionnaire has a question, and then there's responses to that question, which are normally in a word format. So it'll be, you might say, what is your sex, male or female? So you have the word male and female there. But when we analyze the data, we don't work with those words. We convert those words into numbers for analysis. So we'll code male as 1, female as 2, for example. And then we capture that information in a number format. If you've got the word format, you can do analysis with it, but it's very limiting what analysis you can do with words statistically. So we always convert the information into some kind of numeric format. You can work with words, but the kind of analysis you can do with words is not. It's a alphanumeric field. We call it an alphanumeric field, and you can sort of run frequencies of that information. You can do tables and things, but you can't do any statistical analysis on a word-based response unless it's been converted into a number. Okay, and then another thing that happens is if you're taking information from one electronic format into another. So, for example, you might have data in Excel, and then you want to convert it or move it into a statistical application for analysis. You might sometimes people will use cut and paste. But that's quite, you need to be very careful when you're cutting and pasting because you might end up moving the wrong information into the wrong cells. So we have a technical assistant who prepares data sets, and he sometimes uses cuts and pastes, and that can lead to mistakes. So you have to really check you have to have somebody else who checks the data once that's been done. So if you are doing any cutting and pasting, you could also have a situation where you obtain data from a source. It might be a company or from online on a website, and then you want to cut and paste and add that data into a database. But you need to be very careful when you're doing that cutting and pasting to make sure that everything goes into the right columns or the right cells. Okay. And then another problem with students, which I'm pleased to report is a rare kind of problem, is that students make up their data. So we've had a few cases in my many years at UJ where students have made up data. In fact, I had a colleague who had a problem with a student that she was supporting the other day who seemed to have made up their data. So that can be, usually we can pick it up quite easily. So it's just something that we can identify relatively easily, but it does happen. And as a supervisor, it's something that you need to be cognizant of, but it's a very rare kind of thing that occurs. So certainly in my experience anyway. So the good thing is it's not something that happens often, but it is something that one needs to be aware of as a supervisor. Okay. So it's very important to create a code book which describes the variables being measured in a study. So I'm just going to load two files quickly. I'm just going to load this file here, and I'm just going to toggle between. I need the Afrobarometer code book, and then this questionnaire. All right, so I'm just going to stop sharing this presentation, and then I'm just going to share a Word file quickly. So this is more for a questionnaire, but you could use this for any kind of instrument that you're using for measurement, where you have some kind of construct. So in this case, this is an education example. So what we're doing here is we've got the construct, we've got the definition, and then we've got information about how that variable is going to be measured. So this goes back to what we were talking about in earlier sessions about the constructs that we're going to be measuring, how they're defined, and then how they're going to be operationalized. So this is a table showing that we have this construct called professional development improving practice. I hope you can see that on the screen. Can you just let me know that you can see a Word document on the screen? Can somebody confirm, please?
Yes, we can see
Yes,
it.
okay, thanks, thank you. Yeah, so you've got your construct, and then in this case, it's professional development improving practice. The definition of that concept in this particular example is a good vocational training, encouraged for the further development of staff, as articulated by in-service training opportunities and so on. And then that construct is operationalized with an instrument that uses 26 statements. So there'll be 26 statements measuring that definition. And then the item type is dichotomous items and Likert scale items. So it's got two different forms of questions. Dichotomous item would be like a yes, no. And then a Likert type scale item would be a strongly agree, strongly disagree kind of scale. And then they indicate the coding for the dichotomous items is no equals 1, 2 equals yes. And then the Likert scale is strongly disagree through to strongly agree. And then the possible analysis that you can do with those particular questions would be frequencies, cross-tabulations, scale analysis, and correlations. But you obviously want to link that to another variable, which could be, for example, school climate, which is the next variable, the next construct in the listing here. So what you're kind of doing here is you're developing a form of a code book to indicate this is not detailed enough, but it's giving you a kind of a summary of the variables which would be in the instrument that you're going to be using. And you could do the same thing for if you're using a piece of equipment, for example, to measure a variable. You could use this kind of structure to indicate what kind of variable it is, how it's being measured, and then what kind of variable it is in terms of the measurement. So we'll come to that a bit later as well. Okay, I'm going to stop sharing that, and I'm going to move to another example. So with this example here, this is a question. I'm not going to spend long on this. This is an example of a questionnaire called the Afrobarometer questionnaire. It's a nationwide, in fact, it's an international measurement that they use to measure various social issues. In this case, it's democracy and governance in South Africa. So this is the questionnaire. I'm just showing you the questionnaire as an example of what it looks like. So for example, we've got respondent number, a fieldwork number, and then there's a range of questions. So what province is the questionnaire being administered in? And then the following questions are the following services present in the primary sampling unit, electricity grid, piped water, and so on, yes or no. And then there's a whole range of questions. So as you go through the questionnaire, there's a whole range of questions which are asked from the participants. So, for example, in general, how do you rate your living conditions compared to those of other South Africans? Much worse, much better. Looking back, how do you rate economic conditions in this country compared with 12 months ago? Much worse, much better. The survey was done some years ago, so it's not a current survey, but they might, I think, I'm not sure if they're still doing, they might have a current version of the Afrobarometer because they do repeat it every few years. Okay, so this is the questionnaire. The code book basically kind of goes into detail about the question. So I'm just going to stop. In fact, I just need to toggle. I'm just going to stop sharing this window. I need to toggle to another window. I think I've just been showing you the. I don't know what you're seeing because I can't see what you're seeing. So this is the code book for that survey. So this is the Afrobarometer code book. So if we go to the table, I'm just going to skip through the table of contents. So the first question that they focus on is the country, because the survey takes place in different countries. So they would identify that that particular survey had taken place in South Africa, and South Africa will be listed on in the country codes here. It's code number 28. So then you would go into the detail about the. Let's go into there's lots of regions because there's many different countries with lots of different regions. So here's the question about, are the following services present in the primary sampling unit? And then you've got piped water. I think the first one was electricity. So the first one was electricity grid. So it's kind of giving you specific detail about the question number, the variable label for that question, and the values for that question. And then the value labels being 0 equals no, 1 equals yes, 9 equals can't determine, -1 equals missing. So when you get the data set for this, when you look at the data set for this particular survey, you'll be able to use the code book. The data set will contain the variables and the labels and the data for those for that information. But the code book gives you the specific detail about all the questions, what the question is, what kind of labels it has, what the value labels are for that question. And then there's also extra information. For example, here there's a note that the question was filled in conjunction with the field supervisor. So that's extra information that you can give about how that question was answered if you're doing a questionnaire in the field. Not all questionnaires would have this level of detail, but because this questionnaire is open, it's a public access data. So if you wanted to get access to the Afrobarometer information, you could apply to use it. And because it's being used by many people, you need to have very specific detail about what that data set contains, and this is where you get that information from. So even if you're doing a small little survey as part of if your student's doing a small survey for their research project, they should provide this level of detail for their data set. Because it provides the audit trail. So if somebody comes along and says they want to see the data that the student used to check that it's valid and reliable, then they could access the student could provide the code book and the data set. The code book tells the person what that data set contains in a fair level of detail. So that's an example of a code book. Most code books won't be this. Won't have as many variables, and they won't be as intensive as this one. But as the reason for this being so professional and so detailed is because it's a data set which is available to people to work with internationally and nationally, and therefore it needs to be very rigorous in terms of the detail about the variables and so on. Okay, so that's an example of a code book. So I'm going to go back here. What am I doing next? So I'm just checking up here. Okay, so now I'm going to ask you to do a little exercise. I'm just going to go back to this slide here. All right, so I'm going to give you an example, and I'm going to ask you to, it might look a bit complicated, but it's not that complicated when you sort of focus on the main variables. So the example is that there's in the mining industry, they refer to wood pencils. These are big sort of wooden pencils. They call them pencils. They're big wooden sort of, I'd call them, they're like tree trunks, which they're used for propping in mines to prevent collapse within a mine shaft. So, and if they're left to dry out, they will deteriorate. So they get what they call cracks in the wood, and that's a serious safety risk in a mine. So if the pencil which is propping up the mine starts to crack, the pencil will eventually break, and that will lead to it won't be providing any safety within the shaft. So when you treat these pencils with water, it can improve the lifespan of the pencil. So the idea there is that if it's got some moisture to it, the cracks aren't going to occur, or it'll take longer for the cracks to occur. So I want you to imagine that you're a researcher and you want to establish which of 3 treatments will elicit the longest lifespan. So the 3 treatments are no water treatment, watering of pencils 1 time a week, watering of pencils 3 times per week. There's going to be 20 pencils per treatment, so there's going to be 20 records per 20 items per treatment. And then the lifespan will be measured based on the number of cracks that appear in the pencils, where a high number of cracks is indicative of a greater deterioration. And the number of cracks is measured by counting the number of cracks on the head area of the pencil, because that's the most sensitive area of the pencil. It's the most vulnerable area of the pencil. So for each pencil, the number of cracks will be measured 4 times over a 3-week period. At time 0, which is the start of week 1, at time 1, which is the end of week 1, time 2, which is the end of week 2, and time 3, which is the end of the week 3. And so for this example, I want you to think about developing a code book for the study and also develop a data capture sheet for the design. So I'm going to give you a blank Excel sheet to work with. I'm going to switch to Excel now. So the example here is that we've got these, just to repeat, we've got these wood pencils. They're like sort of big, they're not small little pencils. They're like big chunks of wood, big cylinders of wood, which are used to prop up. Think of a very large pencil, a very giant pencil that's being used in a mine shaft. They're used as props. But when the pencil, if they're left to dry out, the pencils will crack, and that could lead to safety issues because the pencil will deteriorate and it will no longer, it will break, and it won't hold up the shaft. So we've got 3 treatments. One where there's no water treatment, one where the pencils are watered 1 times per week, and another treatment where the pencils are watered 3 times per week. There's going to be 20 pencils per treatment, and we're going to measure cracks 4 times at time 0, which is the start of week 1, at the end of week 1, and then at the end of week 2 and the end of week 3. So to kind of solve this puzzle, you need to work out what the variables are that we're going to be working with. So who can give me an example of where there's basically 3 variables that we're going to be working with here? So what are the 3 variables that we're working with? Let's start with that as let's start with that for the code book. So we're going to have 3. There's 3 things that we're going to be measuring in this for this particular activity. So I'm going to just stop sharing that, and I'm going to share an Excel file, a blank Excel file. Well, it's not I've got the example in the Excel file, so you can still see it. Okay, so this is the example, just repeat it. So what are the three variables that we're going to be working with in the study? So for our code book, we need three. I'm giving you a hint. We've got three variables for our code book. What are our three variables going to be? I have shared this, haven't I? Wait a minute, I have, yeah. Yes, I am, yeah. I'm sharing an Excel screen with you now. Okay. I'm not going to say anything else until somebody answers. Yes, Nicolene, yeah.
I think Andre beat me to the punch, but it's going to be the treatments, the cracks, and time.
Yes, yeah, okay, good. Sorry, I didn't see that that's information there. Okay, so treatments, number of cracks and time. Okay, so we've also got we've also got the we need another variable, which is the number of the pencil, but that's fine. Okay, so we're going to have, let me just go to this farm. I don't have the blank one here. Okay, so I'm just going to put the code book over here. Just going to keep it quite simple. So we're going to have a pencil number because we're going to have 20 pencils, remember. Okay, so that's the number of the pencil. Okay, and then we're going to, our dependent variable is the number of cracks. Okay, and that's going to be measured with a variable which is basically just the number. So we're going to have four measures for that. So I'm just going to, okay, so the treatment is going to have three categories. So one would be equal to no water. Two would be equal to water, I think it's one time per week. And then three would be equal to, could just carry on that. And then three would be equal to twice a week, I think it was, right? Yeah, 3 times per week. Okay, so that defines the treatment. So we'll have a treatment variable which would be which would indicate which treatment is being used, and then that would be there'll be three categories for that. The first one is no water. That would be code 1. Code 2 would be the watering once a week, and then the wetting the pencil once a week. And then the third category would be wetting the pencil 3 times a week. Okay, so let me just put that in there. The wrong column here. Okay, pencil number would range from, we can do it from 1 to 20, or we could do 1 to 60, depending on how we want to number the pencils. So we could number 1 to 20 within each treatment, or we could just number the pencils 1 to 60, and then we can distinguish between the pencils within the 3 treatments. So there's different ways we could number those. Okay, then so we've got number of cracks at time 0. Sorry about this, time 0, and then we're going to have more that we're going to have four variables there. So I've got a very sticky keyboard here. Time 1. We're going to have cracks at time 2, and we're going to have cracks at time 3. So those are the all 4. Yeah, depending on what. Yeah, we can. So that'll be the cracks, the number of cracks at the start of the process, before we start doing any treatment. Then we're going to have the cracks at the end of week 1, the cracks at the end of week 2, and the cracks at the end of week time 3, and that's going to be measured in the number of so it's a raw number that we measure there for each period of time for each pencil. Okay, so it's just a raw number that we measure there. Okay, so we've got this. That's a sort of rough idea of what the code book would look like. So how do we put this into a data set? So let's imagine we're going to capture this data in Excel. So we wouldn't have this information at the top here. We'd start in the first cell at the top here, but let's imagine this isn't here. We're going to start at let's imagine this is the top of the spreadsheet. So what is the first piece of information that I'm going to put into the cell if I want to capture data into the sheet? What's the first piece of information that I would use?
The pencil number.
Okay, a pencil number. So whenever you are measuring something, you always need an identifier for the record. So that pencil number it's one of the identifiers that you're going to use to identify that particular pencil. So I'm going to number them 1, 2, 3, 4. If I was capturing data, I would number them 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Okay, so as I said, you could go from 1 to 20, or you could go from 1 to 60, depending on how you're going to how you want to number them. It would work either way. If you want to give each pencil a unique number, you could number 1 to 60. If you want to number them within the treatments, then you could number 1 to 20 and 1 to 20 and 1 to 20. What's the next variable that I would put in here?
Which treatment was allocated?
Okay, yeah, treatment. That's whoops, wrong file. Okay, this is the next treatment. Okay, so treatment is the one of the key independent variables for our design. So we would want to put treatment into the as a sort of main variable. One of the sort of it is a significant variable. They're all significant variables, but this is one of the key variables that we're going to be using for comparative purposes. So that should be one of the first variables that we consider capturing as part of the structure. So and then remember, we're going to have treatment 1, treatment 2, treatment 3, and so on. So I'm just going to break this up here so we can see what happens. Just going to pretend there's data here, which there isn't. I'm just going to put that in there. So let's pretend we're going to go on to 21, 22, 23, 24. Oops, 24. So this will be treatment 2. So remember, our treatments are coded 1, 2, 3. So we'd start with, you could put them in different orders, but you need to designate that treatment as being 1 or 2 or 3. So in this case, I will know that pencil number 1 is part of treatment number 1, and pencil number 21 is part of treatment number 2. So I can identify, it allows me to identify which pencil is part of which treatment. I could also number this 1, 2, 3, 4 as well. It doesn't make any difference really, because I can see that those are pencils within treatment 2. So I know pencil number, yeah, and obviously if you were doing this experiment, you would know where the pencils were located and so on, and you should know where they're located, so you'd be able to know, even if they've got the same number, you'd know that they are within different treatments. Okay, then we've got the pencil number and the treatment covered, and then we also need to take into account the number of cracks. So we've got 4 time periods. So how would you structure the capturing to take into account the time and the number of cracks? So I'm going to ask a question. Should we put time in here and then have a time 1, 2, 3, 4, or 0, let's call it 1, 0, 1, 2, 3 for pencil number 1. I'm just going to move this out here. I'm just going to change this. Whoops, this keyboard is terrible. I'm just going to move this down here temporarily. So should we do it this way, where we have pencil number 1 repeated 4 times for time 1, and then we would have number of cracks here as the dependent variable. Okay, and then this might be 0 cracks, 0 cracks, 2 cracks, 1 crack, for example. Is that a possibility?
Wouldn't it be better to make columns C, D, E, and F just the number of cracks time 0 until time 3? Then just capture the number of cracks under those time frames.
Okay, why would you do it that way?
So you can have one line for your pencil with all the data in there.
Yes, yeah, okay. So it depends on, yeah, so that's the correct way of doing it. So this wouldn't be a good way of doing it, because you actually want to, when you do the analysis, you want to be able to track the change over time. And if you format the data in this way, you won't be able to, it's not paired. So you've got each time period as a separate instance, and it's not paired to the earlier time period. So the correct solution is, as you've suggested, would be to have time 1, or time, let's call it time 0, time 1, time 2, time 3. And this speaks to this issue of making sure that your data is in the correct format. So this would be 0, 0, 2, 1, for example, for that particular pencil. So, and then we would repeat that structure for the other pencils. Okay. So, because we want, in this instance, we want to be able to see whether there's a change in the number of cracks over time. So let me make this more realistic. Let's make this 5. So, because we would, if there's no water, we would expect to see no wetting of the pencils. We'd expect to see an increase in cracks over the time period. So because we are doing a time-based analysis, we would want to do what we call a repeated measures ANOVA, or what we call a Friedman test for this analysis, to see whether there's an increase in the number of cracks over time. If we put the data in a stacked structure where it's on top of, the time is on top of each other, that won't allow us to do that analysis. It's the wrong structure for that kind of analysis, for the time-based analysis. So it's important to, I'm using this example because it's important to structure the data correctly for the kind of analysis that you want to do later on. Okay, so that's the correct structure would be to line up the data across the time period, across the rows for the time periods, rather than stacking it for the time periods. There are other instances where you might stack the data, but that's where the pairing of the data points is not that important. It wouldn't be important to pair the data points. But in this case, because we want to see if there's an increase for each prop over time, each pencil, sorry, then we need to make sure that the data is aligned in the rows rather than in the columns for the time. Okay, so we'd repeat that kind of structure for each pencil, basically. Yeah. And then and that's the correct structure for this kind of analysis. If you weren't doing a time-based study, you could stack, if you had a different kind of variable that you were concerned about. If we weren't concerned about time, for example, we could just stack the data. The treatments are stacked on top of each other because we're comparing the treatments. That's one of the variables we're using. But the time we want to do a time-based analysis, and for that we need to align the data in the rows, not in the columns. Okay, Excel is not a great program for capturing data. It's partly because sometimes when you have data structure, the Excel works best capturing data. So the variables sit in the columns, and your cases sit in the rows. But it's not the easiest way to capture data in that structure, because if you have a questionnaire, for example, the data goes down rather than across. So it's not, we use other programs to capture data and I'm just going to show you an example of that quickly if I can get the program to run. So I'm just going to save this file quickly. So that's an example of a very simple code book and getting a data structure which you can then import into a program for analysis. We wouldn't normally use Excel for the analysis either. So that's just another point. I'll show you another example of how we get Excel into SPSS a bit later. Okay, so that's an example of how you'd set up a simple data set. I'm just going to have to run another program quickly just to show you. So we use a program called Epidata for capturing Epidata entry client. I just need to find a project. Okay, I'm going to open this one. Okay, so let me share this. Epidata is a free program that you can get online. And you should see on the screen now Epidata entry client with case number and so on. Okay, can you see the Epidata file on the screen?
I only have a blank screen on my side.
Okay, let me try again then. If I can get this to, might not show up. Share. Okay, is there anything showing now?
Not at the moment.
Okay, I think it's probably not displaying. So I'm not sure how else I can, maybe I do a print screen. Let me just try print screen quickly. If it doesn't work, I'll just move on. Let's just put this into Word, close, just open a new Word file. Okay, okay, so this is, I'll try this rather. I think it's probably that the Epidata is not showing up on the screen, but I can get it into Word here. So this is, you should see on the screen a Word file, which has got a copy of that Epidata screen in the file. Can you see that now?
Yes, we can.
Yeah, okay. So the reason why we use Epidata is you can set up a file which you have to create the file structure. But when you're capturing a questionnaire or some records, if you might be using medical records or something, and you need to capture the data, Epidata allows you to capture going down rather than going across. And that is a much better structure it's much easier structure to work with when you're trying to capture data. So this is an example of a questionnaire that we've used, that one of the students we've supported has set up, and we've created a data capture file to capture the data in a structure going down rather than going across. And it's much easier to, if you've got sort of 300 questionnaires that you're trying to capture, it's much easier to use this kind of capturing system rather than something like SPSS or Excel, where the formatting is not ideal for data capturing. SPSS does have a data capture sort of add-in as well, but we don't use that. We use Epidata. It's free and it's fairly easy to use once you know how to use it. So if you're going to be doing a lot of data capture, I would recommend that you look at something like Epidata. You have to create the file in the Epidata manager, and then you open the file in Epidata entry client to capture the data. But it's much easier to use. It's the structuring of the file is much better for data capturing than it would be using something like Excel, for example, or SPSS itself. So we sometimes switch between applications to depending on what we're trying to do and what for the efficiency and so on. Yeah, so I prefer to use something like Epidata for capturing a lot of, if you've got a lot of data. If you've got a small amount of data to capture, something like Excel is fine. But if you've got a lot of data, then you want to be using something like Epidata, which is designed for, it's more orientated towards capturing data. Okay. All right. And then, yeah, so let me just move back here. I'm just going to close this program down, leave it open. I'm going to share back to my slides.
Can I ask a question, if I may?
Yes, absolutely. Yeah.
So after capturing data in Epidata, do you then export the data into an Excel spreadsheet, for example?
Well, you'd move it into something like SPSS. So Epidata
Okay.
has a function to export to SPSS. So we normally export from Epidata to SPSS directly. There can be, you have to be aware of certain things, but it works pretty well. Yeah. Epidata doesn't have labels and things attached, so you have to attach the labels and things later. I'll explain that a bit later. But you can export from Epidata into SPSS, or you can also, it also exports to Stata, and I think you can export to Excel, but we would go straight to SPSS rather than to Excel, because we're not going to use Excel for the analysis. Yeah.
Yes. Okay, thanks.
Yeah. Okay. So for capturing data, you can do it yourself using an app in the field. So there are certain applications that one can use to capture data. So if you're doing field work, I haven't used any of these myself, but there are applications where you can actually capture directly into if you've got a cell phone, for example, or a tablet, you can capture data while you're doing the field work. You can also capture into Excel, SPSS, or Epidata, and I've just shown you an example of an Epidata data capture sheet. You could also use online surveys. So you could use something like, if you're using an online survey for your study, you can obviously the online survey software captures the data for you, and then you can export that into Excel or SPSS. Usually most of the online survey applications have an export function. Some of them do analysis as well, but at a very usually at a very simplistic level. Yeah. You can also, StatCon, for example, does support, we use a program called Question Pro, which is a very sophisticated online survey application, which we sometimes help staff and students with their online surveys to use that program. And you can also get a professional data capturer to capture your data. So for example, in StatCon, we have an in-house data capturer who can help staff and students with data capture if they can't do it on their own, or if they've got a huge amount of data that needs capturing. You need to set up a code book, and if you're going to do it, you need to set up a capturing shell. And that could be in Epidata or Excel, or you could use SPSS as well. But I wouldn't do that unless you've got a small amount of data. And then it's very important to achieve accurate capturing. That's the key thing, is there's lots of, you don't want to get dirty data when you're capturing. That's the key thing. Yeah, so those are the key things about capturing data. Okay, then we're going to move on to analysis. So once you've got your data captured, we're going to start looking at analysis as a topic. So the question is, what do you think of when you read or hear or see the word statistics or biostatistics and data analysis? What do you think about what comes to your mind when you read or hear those words? And I hope nobody says terror. Nothing yet. Was that typed now? No. Okay, that must have been from the display. Okay, so statistics is defined as the science of collecting summarizing, presenting, and interpreting data, and of using them to estimate the magnitude of association and to test hypotheses. It's a quote from Kirkwood and Stern, which is a book on medical statistics. And then also a quote from Nerusis, who writes texts on SPSS manuals for statistics. Data analysis is the art of examining, summarizing, and drawing conclusions from data. Good data analysis involves a mixture of common sense, technical expertise, and curiosity. So I've used these two quotes because the one kind of mentions the science of collecting, and the other talks about the art of examining. So it's not, yeah. Although statistics is a very scientific discipline, there is an art to analyzing data as well. So I've used those two quotes deliberately to bring out the concepts of science and art in this idea of data analysis. So if you're a qualitative person, you shouldn't be scared off from doing a statistical analysis, because there's an art involved to it as well. Okay, I just want to make a note. We won't have time to go into a lot of detail about the debates, but there are, although there's very standardized methods and procedures for statistical analysis, there's still a lot of debate about issues. So some of these debates occur at a conceptual level. So, for example, there's a debate about frequentist versus Bayesian inference in statistics. It also occurs at the methodological level. So, for example, the debate about use of p values or p statistics versus which are probability statistics versus confidence intervals. And then also at the level of specific statistics, for example, when we do structural equation modeling, there's debate about what a good value is, what an appropriate value is to demonstrate good fit statistics when you're doing modeling. So there's debates at lots of different levels within this field of statistics. It might seem like it's a fairly structured, standardized field, but there's lots of debate that occurs within the field of statistics. Okay, so data analysis, it's not, when we do data analysis, we start with what they would say is a screening phase, and that's what they mean by that would be where you look at the data to check for. So after you've done data capture, there can be mistakes with the capturing, and there can also be people might also have given you information which is not necessarily reasonable. So part of the screening phase is to go through the data, the information that you have, and to look for odd data, mistakes in the capturing, outliers, unexpected results. And so it's a form of sort of data validation that we do. So for example, a simple example would be, let's say, for example, you've asked the question, what is your sex? And you've got to answer male, female. And then you should only have a code 1 and 2 for that response, but then you end up with a 5. That 5 shouldn't be there. So you'd need to go back and look for why the 5 is there. Is it a capturing error? Or did somebody write an answer did somebody provide an answer of 5 which was captured, and then it might not make sense. Then there's the diagnostic phase, at which stage we sort of at that point we'd be sort of analyzing the data for distributions. If you have an interval variable, we'd be looking for normal distribution, for example, looking for outliers. Sometimes you get extreme values which could be real, or they might be unrealistic. So and when we run analysis, when we use descriptive statistics, for example, the program will identify if there's outliers. And then the treatment phase is the phase where we decide what to do about these unusual cases and the extreme cases in the data set. Do we correct them? Do we leave them as they are? Do we adjust them? There's various things we can do to sort of adjust data if there's problem data. So it's not a complex process. it says here it's a complex process, which it is, but it's not actually that complicated once you know what you're doing. It's not, it shouldn't be an intimidating process. I think that's what I'm trying to say. Okay, so data analysis, it involves providing a clear description of the data. It involves identification of typical and atypical features in the data. So that will be values which are sort of within the norm, and then values which are extreme or unusual. It also involves bringing to light differences, relationships, and other patterns existing in the data. And that's why we do data analysis, is to look for relationships and compare groups and so on. And then obviously we're going to use it to answer the research questions or testing hypotheses. So that's what we as researchers do, and that's what the students will be doing as part of their research design or their research journey. And then statistical analysis, more specifically, it's obviously part of data analysis, has a number of purposes. Not all of them might be relevant to a project, but this is what statistics can help us achieve. So we can summarize data and reveal what is typical and atypical within a group. We can show relationships between and among variables. We can show similarities and differences between groups, and we can identify error that is inherent in a sample selection. So these are some of the kinds of things that we can get from doing analysis. And when we get to the statistical analysis, the particular kinds of tests, you'll see that certain kinds of tests will show relationships between variables, and then other kinds of tests will demonstrate differences between groups. So we use different kinds of statistics to get to those different purposes. We can also use statistics. Now we're moving more towards this idea of statistics for inferential purposes. We can test for significance of findings using statistical analysis, and then we can support research. The statistics also support researchers in making inferences about the population that we've sampled from. Statistics also help us condense a vast body of data into an amount of information that we can process in a more meaningful way. So that's usually when we're working with data, we have a lot of data points, we have a lot of variables, and the statistics help us condense that information into something that's more manageable. And then we can also identify patterns and relationships within data that may otherwise go unnoticed. So if we weren't doing this kind of analysis, we might not see the patterns. Sorry, just to make a note, it's also what a comment that Dr. Tony made earlier was about in a qualitative way, was going into, when you go into the field, you sort of identify issues that you weren't aware were there. And this is a lot of the kind of purposes of statistical analysis would be similar to the purposes of qualitative analysis, but except with the quantitative analysis, we are able to do tests for significance, and we are able to make inferences about the population, which you might not be able to do as easily with the qualitative analysis. But certainly things like showing relationships among variables, you could do that with qualitative analysis as well. And you could also show similarities and differences between groups using qualitative analysis. We just do it in a different way. Okay, so statistics. So who uses statistics and why? So businesses use statistics to detect market trends and sales results. People in education use statistics to determine teaching method effectiveness, for example. Governments use statistics to detect changes in population. Demographers, government in population demographics and effectiveness, they might use statistics to measure the effectiveness of public policy. People in the sports field use statistics to examine player and team successes and their capabilities. So there's many ways we can use statistics in different disciplines. And even in philosophy, there is probably space for statistics. So, so we're going to, yeah. So I'm going to skip this example and this example. I'm going to go to two other examples. So just an example of medical studies. So statistics are often used to understand, in the medical context, statistics would be used to understand how different factors are related. So, for example, you might want to correlate how weight, height, smoking habits, exercise habits, and diet are related. And then if a certain diet and overall weight are found to be negatively correlated, the medical professional might then recommend the diet to an individual who needs to lose weight, for example. So that's an example of a medical kind of context. And then in a manufacturing example, statistics could be used to monitor the efficiency of a process. So manufacturing engineers could collect a random sample of widgets from an assembly line and track and measure how many of the widgets are defective. And then to do that, they would then you'd have to make a judgment about what an acceptable error or sort of defect rate was. And to do that, we would use a test we'd sort of decide what an appropriate proportion was to be faulty, and then we could do a statistical test to determine whether the number of widgets we have which are faulty is below, above, equal to that acceptable value that we would accept as being, because there always will be some defects. So how many defects would we be prepared to accept? Okay, so these are some examples. So yeah, generating statistics can be quite scary, and then engaging. I think what scares students off statistics is having to work with formulas and complex calculations. But we have we have technology software programs which help with generating the statistics. And there's also sometimes consultants who the student can get support from to help them with the analysis and interpreting the statistics as well. And we'll talk about the types of statistics in the next contact session. I'm not going to talk about those today. We'll move on to those in another session. So how do you analyze data? You can do it by hand or with a handheld calculator. So when I started doing research, we didn't have computers. We had one computer in a sort of lab in those days. So in the early days, we used to have to calculate statistics by hand or with a handheld calculator, but we don't have to do that anymore because we have software. So, for example, in StatCom, we use IBM SPSS for a lot of the analysis that we do. There's also other software. I'll talk about the software in a minute. But then they have UJ, for example, has site licenses for postgrads to access SPSS and Stata for general statistics, and then AMOS for structural equation modeling. You can also do statistical analysis with Excel, but Excel is more of a spreadsheet accounts-based system rather than for statistical analysis. So I've got a book where you can use Excel to do quite sophisticated statistical analysis, up to regression, for example, but it's not designed for that purpose. It's not a software. It's not a statistical analysis program. It's more a spreadsheet database, so a spreadsheet accounting application. And then there's many different types of software, and I'll talk about those in a minute. And then if you can't do it yourself, you can also find somebody who can help you. So, for example, StatCon has consultants who assist with analysis, and there are also private consultants out there who can help with analysis. But it's good to learn how to do it yourself, in my opinion. Okay, so statistical software, there's different packages that we use. So IBM SPSS is a general package. It used to be called the Statistical Package for the Social Sciences, but it's now just called SPSS. Because many different disciplines use it. It's not just the social sciences that can use SPSS. Stata is also a general software package for analysis. And there's also other programs called Statistica, GenStat, SAS, R, and then also Excel you could also use for doing some analysis. R is so just to note that these different programs have different learning curves. So SPSS, we use SPSS because it's very easy to for a student to learn how to use it. R is much more difficult to learn how to use. So it's not as easy to use a program like R as it is to use a program like SPSS. But having said that, R, for example, has a wider range of tests than SPSS does, for example. So it's got a range of statistical procedures that you can use if you're using something like R. It's got a lot of add-ins that you can use, which SPSS wouldn't have. And then there's also a cost issue. So programs like SPSS is very expensive to buy on its own. So with something like SASB, R is free. So there's different. It's free software. So there's different costing involved with these different programs as well. There's also lots of different specialized software, which are used by for particular because they're specialized in a particular procedure, or there's a particular discipline that has a preference for using that software, usually because of the procedures that the software supports. So, for example, MATLAB it's a modeling software application, and it's used a lot by the engineering community. eViews is a program which is used a lot by the economists. One of the reasons why is it's very good it's good to use for something like longitudinal analysis or time series analysis. There's a procedure called structural equation modeling, which there's a number of programs which you can use for that analysis. And I use a program called EQS, and we also use a program called Smart PLS. And then there's other programs like AMOS, which is also used at UJ, Lizrel, M+. You can also use R, and then also Stata. And then as the quote says, each of these packages has its own advantages and disadvantages depending on your research objectives, data characteristics, model complexity, and technical skills. So there's different reasons for using the different programs. Yeah, and if you're doing something like RASH, which is an item analysis, there's programs called WinSteps and RUM, which are specialized for doing RASH analysis. So depending what kind of work you're doing, you might need to get a specialized program for the analysis. It depends on what work you're doing. Okay, so I'm just going to start. I need to run a program quickly. I'm just going to start a program called SPSS, which is what we use for analysis. I just need to get it loaded. I'm just going to stop sharing this file. Yeah, so we use a program. We mostly use a program called SPSS, which I now can't find. Where's it gone? It's moved on my menu. Sorry. Okay, I just need to remember about the windows here. So I'm just going to share the screen. I hope this works. Okay. You should see on your screen a sort of spreadsheet type looking thing. Can you see that?
Yes, we can.
Okay, good. Okay, so we use a program called SPSS for most of the analysis that we do. It's a very powerful application. One of the reasons why we use it is because it has most of the statistical procedures that you would need to use. And the other reason is that it's got a very friendly user interface. So it's a relatively easy program to learn how to use. It doesn't have every software procedure in it. So it's got some limitations, but generally it's fairly user-friendly. If you wanted to import, I'm just going to give you a demonstration of how to import an Excel file into SPSS. So if you had if you wanted to open a data file into, I can just do it and import here, import data. I'm just going to go to another directory. Yes, yeah. Okay, so this is going to be this one here. Let's get rid of this window, open. Okay, so I'm just going to import an Excel file, which I should have showed you what it looks like. It's a fairly simple file with just some cases and some variables. It's a very straightforward, simple Excel file. So you just go to Data Import, and you find the Excel file that you want to import. And then it'll ask you some questions about reading variable names, percentage of values that determine the data type, ignore hidden rows and columns, and so on. And then if your data is set up in a fairly simple way, it should import it it should read it quite accurately and then import it. The times we have problems with imports are when there's unusual characters, or there might be a very long sort of alphanumeric variable in your file, for example. Okay, and then we should end up with you should see a data file on your screen now. I hope can you just tell me what you're seeing on your screen?
We're only seeing the tiles of all the attendees at the moment.
Oh, okay, so let me just try that again. Just go back to share. I must have lost it when I ran the thing. Okay, so this is the file that's been imported. So you should see a file which has got case, years, months, A2, A3, and so on.
Yes, we can.
Yeah, okay. So what I've done is I've just basically imported a data file which has got it's based on a questionnaire. So when you import the file into SPSS, it won't have labels and it won't have labels attached to the variables. It's just got the data and the variable identifier. In SPSS, there's two views. There's a data view and a variable view. So if you look at the bottom left of the screen, there's a data view. I think I've just toggled to it. So you should now see some data on the screen. Are you seeing that?
Yes.
Yeah, okay. So this is the data, case 1, case 2, case 3. And then the first person is 7 years old and 0 months. The second person is 6 years and 5 months, and so on. So that's the data view. And then there's also a variable view, so the data view shows you the data. That's like the database, or the data that's been imported. And then the variable view, that's where you allocate information about the variable. So case, I've imported the names from Excel. So case is the case number. So if I wanted to give that a label, I would go to the label window, which you should see, and then I would say case number, for example. Okay, so that would be and then case numbers don't have values. So I'm not going to add a value label to that variable. So this is where we give the variable information. So years would be the age in years of the child, of participants, of child, because I think these are all children for this study. Okay, age and years. So this is where we can put our labels into the file. So we need to put labels in. So when we run the analysis, we've got a label which is attached to the information so that the information makes sense. If we didn't put labels on, we could still run the analysis, but we won't know what the information is referring to. So the labeling of the variables and the values is important. Okay, the other things here are the type of variables. So the different kinds of variables you can have in SPSS are numeric, or you can have string variables. Most variables we will work with are numeric variables. You can also have date variables and things within SPSS. So, but most of the time we work with numeric or string variables. So I'm not going to go into a lot of detail about that. The width is just the how wide how many columns the information is taking up. So because we've got more than 100 cases in this file, we'd need at least 3 columns for that number. So that's the reason why we've got 3. There's no decimals. We're not using any interval variables in this file. If you had a variable where you needed to use decimals, you would allocate decimals to the variable. I'll come back to the values in a minute. The missing data is if you want to allocate a value as missing. So, for example, that code book for the Afrobarometer survey, there were some they were using -1 to designate missing data. So if you wanted to allocate missing data, you can allocate that under the missing column. The columns is just how wide the variable is appearing on the screen. So each of these variables is 12 columns wide. So if you want these to be thinner columns, you can change the column width. The alignment just means the numbers occurring in the right-hand side of the column, not the left or the middle. So you can adjust that, but usually we would want it to be on the right-hand side. The measure is important. So we're working with scale or nominal, or the options here are scale, ordinal, or nominal. And I think we spoke about those different kinds of measurements in a previous session. So this is where we define what kind of variable we're working with. So the case goes from 1 to it's a number increasing in increments. So that's why it's being designated as a scale variable. Some of these nominal variables might actually be scale variables. So the age in years should actually be a scale variable. So I would probably change that format. And also the number of months would also be a scale variable as well, because it's the number of it's the age and months of the child. Okay, so that's that would also be more like a scale variable than a nominal or an ordinal variable. Okay, A2. I'm just going to go and look at the questionnaire quickly and see what A2 is. Hope I've got the questionnaire here. Yeah, so A2 would be the question for that was how long has your child been taking ART? So I'm just going to copy this from this questionnaire, and I'm going to put that into the, I think I would, okay, yeah, I shouldn't have done that. Control B, nope, okay, that's not working. Just try that again. Copy, I'm just going to open another file here just so that I can get rid of the other stuff. Paste. Okay, I'm just going to try this now. Edit, copy. Okay, let's go V. Okay, so this is the question. I'm just copying the question in here, which is how long has your child been taking ART? I'm just going to do one example of these just to show how it works. So when you're adding in the labels, this is how you'd kind of need to do it. Also, just to say, I use something called syntax to run commands in SPSS. So I would actually create a syntax file which has the labels and the values in, and then I'd attach it using syntax. But if you're not sure how to use SPSS, a good way to start is to do it in the way that I'm doing it here. Okay, so the question label, this is the variable label, which is the question would be how long has your child been taking ART? And then the value labels which are attached to that variable would be, I'm just going to go back to the questionnaire, is less than 6 months, 6 months to 1 year, and more than 1 year. So I'm just going to add those labels under value labels here. So if I go to value 1, I can go to plus here. You should see a box on your screen saying value labels. Are you seeing that?
Yes, we can.
Okay, so value number 1 is going to be less than 6 months. Okay, so less than 6 months. Just going to do that quickly. Okay, and add that in. The second label is going to be 6 months. I'm just going to abbreviate here to 1 year. And then the third label is going to be more than 1 year. Okay, I'm not going to question I'm not going to go into detail about the usefulness of the labels and things, just that that's what a label would be. I'm just going to look at the next question quickly, just put another one in. Yeah, the next question is, what is the gender of the child? So gender, I'm just going to type in here gender, just to get another label in. And then the labels here, they've only used 2 labels, which is one is male and 2 is female. Okay, so that's those are the labels for the next question. So you continue that exercise till you've got all your questions in the file. You can copy and paste a number of labels in at the same, a number of questions in at the same time, as long as you've got the right formatting. And then you can also copy the value labels that you put in. So I could copy, let's say this was a set of ordinal responses. I can copy those and paste them into, if you've got 10 questions with the same value labels, you can copy those labels and paste them next to those variables. So if you've got if every question is different, it's going to take a bit longer. But if every question is the same, if you've got similar questions or the same questions and the same value labels, then you can get the process of adding labels is quite quick. Okay, I'm just going to save this quickly. Okay, so I'm just going to put here test and then save it. That's not the way. Okay, if I go back to the data view, at the moment, all I'm seeing is numbers. Can you see the numbers on the screen?
Yes, we can.
Yeah, okay. So if I go to the view, if I go to the data view here, and you'll see there's an option here that says value labels. So at the moment, it's not checked. So at the moment, it's just showing the numbers. But if I click on value labels, the value labels that are attached to those numbers appear. So you can see the male-female responses are now showing the label that's attached to the number. And that's what we're going to get when we run the frequencies. We're going to get those numbers coming out rather than the number that's underlying that label. So we want to see the label, but we don't work with word responses when we're doing the analysis. We need to work with these numbers that are here. Okay, so that's an example of how you'd start labeling your data once you've got it into SPSS. So just to go through the menus, the file menu obviously is where you do your open and close and save. If I made adjustments to this file, I would need to save it. You can open data files, you can open syntax files, you can open output files. So we'll go through the output in the next session, but when SPSS generates a result, it creates a separate output file which you can then do things with. And if you might at some point want to open an output file. So this is where you do your file management functions under the file menu. And that's those are the main functions that we use: are open, save. Okay, those are the main sort of options that we would use here. We don't often print from SPSS, so that's something that we wouldn't really use, or I certainly don't use it anyway. The edit menu is when you have your data in SPSS, you're not likely to do much editing of the data in SPSS. I certainly don't do a lot of editing, cutting, pasting, that kind of thing within the program. So you could insert a variable, insert cases. That's where under that menu, if you need to insert a new variable. If you wanted to capture more information for a new variable, that's where you would do this is where you can insert the variable. But yeah, generally this option is not really, I don't use this menu a lot, except for the options menu. So this is where we control what the program looks like. So for example, your file locations, where you want to store your data files, is under that options menu. The way you want your output to look when you generate some output is where you control this under the options menu. So when I run tables, I want to see names and labels. So I've set it up this way. You can change that so that you just have labels or names, for example. So different, my colleagues might have different preferences to what I like having. But this is where you can change your settings for how the program looks, basically. Okay, I'm not going to change anything. I'm just going to close that down again. The view menu, the main function that we toggle here would be the value labels. And we normally have that checked on because it's quite good to actually see the information that's in the columns rather than just the numbers. Sometimes you might want to look at the numbers just for scanning, but normally we want to see what the numbers are representing. Okay, the data menu is quite an important menu. So the data, transform, and analyze menus are the menus that I would use the most in SPSS. So the analyze is obviously where the stats occur, and we'll start working through this menu in the next session to kind of see what's available and how the different functions work and so on. I think we did look at the scale briefly in one of the previous sessions. Okay, the data menu is but before you do analysis, you might want to manipulate variables or change variables, or there might be something that you want to do with a variable that before you do the analysis. So that's usually where the functions that if you want to manipulate the data before doing analysis, it would happen under data or the transform menu. Let's do the transform first. This is where we can do recode. We can compute variables here. So if you want to compute a new variable, that's where you can find the compute option on the menu. I'm not going to compute any. Oh, let me just do, it's not here. Let's just see. Sorry. Yeah, so yeah, I don't know what this data is showing. So let me just check something quickly. All these questions are different, so it's not a good example to use. So under the transform variable, we can compute variables or we can recode. These are two important functions that we would use for manipulating data. So under the compute variable, we can compute, you might want to say compute a dummy variable. So I'm going to just make an example here. I'm just going to call it male. So sometimes when you do a regression analysis, for example, you might want to create a dummy variable, which is 0 for one group and 1 for another group. So I'm going to use gender here and say if gender is equal to 1, which would be male. Sorry, I'm making a BB here. Let's want that to be equal to 1. If it's not working. If gender is equal to 1. So what I'm doing here is I'm creating a dummy variable, I hope, which will be equal to 1 if male is equal to 1. So let's try and run that and see what happens. So I'm creating a new variable, a dummy variable called male, which is equal to 1 if the gender variable, which is A3, is equal to 1. And it should be 0 if it's not male. Okay, so let's do that. And then we should end up with a variable at the end of the file. Let's just check that it's there. Yeah, so we've got a dummy variable here where male is equal to 1 if the gender variable was male. So I've created a dummy variable based on the male responses here. And that you could use something like that in a regression model. I'd have to put the zeros in as well for the female category. But I'm not going to do that now. So that would be an example of computing a variable. You might want to add something up. You might add up different responses or different numbers. So you might say add, let's do another, I'm going to see if we can do this quickly. Just the age is equal to, I'm going to make it equal to age in years divided by, no, times 12 plus months. Okay, so what I'm doing here is I just need to put a bracket around this. I'm multiplying the years by 12 and adding the months to the together. So I'm going to get a variable which is the number of months. I'm going to call this age and months. Okay, so that would be a variable where I'm computing a new variable, which is the age and the yeah. So this person is 115 months old, for example. This person is 140 months old. So that's how you would compute a variable. And I still got that select on though. So it's only doing it for the males now, which I don't quite want it to do. But so let me just take this off. Include all cases, continue, and then click OK. I'm going to change the existing variable. So you have to watch what you're doing. So we've got 84 months for the first person, 77 months for the second person, 101 months for the third person. Okay, so there will be times when you might need to compute a new variable, and that's where you do the compute function. Another function which is important is to recode. So there might be an instance where you want to combine categories into different groupings. So I wouldn't use male, female, but I might use, I'm just going to use this more than 1 year. I'm just going to do a quick frequency of this just to see what the distribution looks like. Oh, in fact, let me just, I'm going to use that. I'm going to use the month, the age variable. Well, let me just see what this looks like first. I'm not getting anything here. Something's not working. So it's gone funny here. Okay, my system has gone, is not behaving. Let's try that again. Interesting. Okay, it's not showing up. My system has gone funny. I'm just going to stop sharing this for a second. I'm going to bring back now. This is the problem when you're working with. Let's see if this works without being on board. It's not working now. MR SPSS is misbehaving. I'm just going to close the program down and open up again because it seems to have gone funny. Try again. Okay, let's just see. Run it again first. Technology. Okay. Okay, let's try this again. I'm just going to try it without putting it online first, just to see if it's working. Yeah, now it's working. So, okay, so I'm just going to come back here quickly. Go back to share. Okay, so it just got corrupted somehow. So I'm just this question, how long has your child been on ART? Has got 6 people, you should see an output file which has got the frequency of the question A2. How long has your child been taking ART, with 6 and 23 parents saying less than 6 months, 6 months to 1 year, and then 124 saying more than 1 year, and 4 saying four with a 4, which is obviously that's obviously data that's been captured incorrectly. So what we'd want to do is recode this variable so that there were so that the 1 and the 2 group were put together, and then the third group was standing on its own, and then the 4 must go into. What you'd normally do is go to the questionnaires and check what should have been there, and if there was a 4 there, then there shouldn't really be a 4 there because there isn't a category for 4. So it's a data capturing problem. So you'd clean the data by putting the correct response in, or you'd allocate it as being missing, depending on what you find when you go back to the questionnaires. So I'm just going to quickly recode this variable into a different, but I'm going to use a different variable. I'm not sure what you're seeing on the screen now. I'm just going to stop share. Can you see an output file, or have I got the wrong thing on the screen?
We could see an output file, but now it's stopped sharing. Now we're back on the variable.
Okay, all right. So I'm going to go to transform, and I'm going to recode. I always recode into a different variable, okay? Because it's not a good idea to recode into the same variable, especially if you make a mistake. Okay, so the output variable is going to be called, I'm going to call it recoded A2, and I'm going to say recoded time on ART. And then we go to, I've created the variable here, and then I'm going to go to old and new values to do the recoding. So value 1 through to 2 is going to be new value number 1. So remember, those are those 2 lowest period categories where there's few children in that less than 6 months or 6 months to a year category. So 1 through 2 is going to become 1. 3 is going to become 2. Okay, I'm going to make 3 number 2 and add that. And then 4, I'm going to make missing. Okay, so I'm going to get rid of those 4s by making them missing. And then I'm going to continue. And then I need to, where am I going to put the labels on? Sorry, I'm sitting a bit of a doof moment here. Continue. I think I need to do that in the variable window. Okay, so I've created a new variable, which is the recoded version of variable 2, which has now got 2 categories. And then if I go to the variable view, I would go to the variable here, and I would add in value labels. 1 would be up to 1 year. And 2 would be more than 1 year. Okay, and that's that would be the new variable. And let me just try and see if I can run it again. If it works now. Okay, and there's the new variable. Okay, so it's got the 2 low groups combined. It's got the one group which is as it was originally, and then the 4 cases which were incorrectly captured are now missing. Okay, so that's how you do a recode in SPSS. And there will be times, but I've created a new variable. Instead of working with the old variable, I don't want to change the old variable in case I make a mistake during the recode. I'm very nervous about making mistakes when I recode variables. And just very quickly, I know we're over time, so that those are the main functions that we would use under under the transform. Then under the data menu, there's a few things that we use here, which would be you might need to sort cases. That's a function that we use sometimes, where you sort the data set into a sequence based on maybe province, for example. You might sort the cases according to province or according to treatment, for example, if you're doing an experimental design. And the other thing we do here is select cases. That's another function that we do a lot of. And so let's say, for example, you wanted to only choose the male cases. You would go to if condition is satisfied, if, and then if gender is equal to 1, which would be the males, continue, and then that's applied the filter. And then it'll say here filter out on unselected cases. So I'm going to click OK. If I go to the data set, which I'm not sure if you can see it, you'll notice that the cases which are not males have been crossed out here. They're still in the data set, but they won't be included in any analysis that we do. So if I run the analysis of that variable that I've just run, again, with just the males, it'll be for a smaller sample. It's only for 63 cases instead of 157. You probably can't see the output window, right? Let me just stop sharing this. So I've got to toggle between windows here. So because I've put the filter on for males only, it's now showing for 63 people only, not for 157, because it's eliminated the female cases from the sample for the analysis. What you don't want to do is eliminate permanently. You just eliminate temporarily for that particular function. So when you use the select function, you make sure that you say, you say here, filter out unselected cases. You don't delete the unselected cases. That would be a bad thing to do. Okay, so that's a function that we often use if we want to look at subsamples within the analysis. So we use that select function quite a bit. You might have a questionnaire, for example, where it only applies to a certain group of people, where the questions only apply to a certain group of people. So you would use the select function to get the responses for those questions. Okay, I'm just going to go back to all cases here. I'm going to reset. And then, yeah, so that, and then what else will be used? Yeah, you might sort cases. There are other functions that we use here, but not so often. So I sometimes use the aggregate function. I sometimes use the merge files function. If you want to join files together which have the same structure, you can add cases or you can add variables. So if you've got lots of data files that you need to add together, you can use that merge files function. Okay, but I'm going to stop there, and then in the next session we're going to move on to the analysis menu and go through different kinds of analysis that you can do with data to explore some of the options on that menu. Okay, so that'll be in the next session on Saturday. All right, so I'm going to end there. Are there any questions? Sorry, I've run over time a bit. Okay, we can blame the late arrivals for that. Okay.
Hi, Richard. Can you hear me?
Yes, hello. Is that Prof. Paulus Zulu?
Yeah.
Yes, hi. Yes, how are you doing?
Very well, very well. I'm sitting with one of your students here.
Okay, good. Yeah, okay.
How are you doing?
I'm doing well, thank you. Yeah, yeah.
That's very great. That's very great.
Yes, great.
Yeah. No, I'm still around. I haven't disappeared.
Good. No, that's very good.
Although quite advanced in age, I must say.
Yes, yeah. I think we're all advancing in age.
Yeah, you're at UJ now.
Yes, yeah. I've been there for a long time now. Yeah.
Yeah, I have been telling this friend that you were doing stats for us. This is your domain.
Yes, yeah.
You've kept to it right through.
Yeah.
Oh, that's great. Thank you. Thank you.
Good. Yeah. Very nice to hear from you again.
Great. Thank you.
Yeah.
Thank you. Yeah, keep it up. Keep the good work up.
Thank you.
I have my postdoc, put it interns here, and one of them is doing your course.
Great. Okay. Yeah.
Yeah.
Good. Okay.
Zamokuhle Makubane.
But you call me wise man.
Yes. Yeah.
Yeah.
Okay.
Great,
Good.
Richard. Keep well. Keep well.
Thanks. You too. Thank you.
Thank you.
Right. Any questions? Okay, I'm going to stop recording just so I've got the thing. Okay.